Okay, so this is going to be number 5 on page 192. Okay, and what I'm going to do is just take you through each one of these problems individually, just for the sake of time in each video. There is one commonality between all of these problems if we're looking for, like, if we were doing what do you notice, what do you wonder kind of thing, right? You can notice that these are all what we call reciprocal quadratic equations, right? Or reciprocal quadratics, right? And so you can kind of see in each of these instances the degree of the numerator is less than the denominator. Okay, and so for each one of these equations, the horizontal asymptote is going to equal 0. Okay, so as I run through each of these components, what we are not responsible for in this unit is describing or talking about anything to do with the intervals of increase or decrease yet. We have not done any of the rates of change, so I'm not expecting you to be able to talk about that. Later on, when we start talking about the last unit of the course, rates of change, then we can talk about all that stuff for all of the functions that we have studied in this course. Okay, so as of right now, all I want to do is just do 1, 2, 3, and then 5, where we finally state the domain and range for each of these problems. Okay, so in problem 1, f of x, okay, I'm going to determine we already determined that the horizontal asymptote is at y equals 0. And then to find the vertical asymptotes, we have to figure out what values of x are going to set the denominator equal to 0. So that means x squared plus 6x plus 5 can't equal 0. In which case I'd be looking for two numbers to factor this and figure out what those x values are going to be. I'm going to need to find two numbers that multiply to 5 and add to 6 so that I can factor the denominator to get the two components that I'm looking for, right? The two components that set the denominator equal to 0. So those two numbers are 5 and 1, and then I can write the denominator as x plus 5 times x plus 1. That can't equal 0, which means x plus 5 can't equal 0, and x plus 1 can't equal 0. Okay, which means x can't be negative 5, and x can't be negative 1. So those are your two vertical asymptotes. Okay, so one at x equals 5, and one at x equals negative 1. So maybe at this point, once we found all our horizontal or our asymptotes, those are our big, like they kind of dictate the geography of these graphs, right? I'm going to draw them on my graph here, right? So let's say the x-intercept or the vertical asymptotes. We'll do those in blue, maybe. Okay. We'll put them. One is going to be here at negative 5. Okay, and one is going to be at negative 1. Now, these are equations. They're a part of your graph. So you need to label them as x equals negative 5 and x equals negative 1. Okay. Additionally, we have in this problem a horizontal asymptote. We'll do that in red, y equals 0. Okay. So again, it's part of your graph, y equals 0. Additionally, don't forget to label x and y. And now we can start finding specific pieces of information to allow us to figure out where the graph is in each of these intervals kind of thing, right? So where's the graph over in negative infinity to negative 5? Where is it in here? And where is it over here? Okay, so we're going to do the next step here in determining, so remember this is I, we're now going to figure out y-intercepts. Okay. So y-intercepts occur when x is equal to 0. And so I'm just going to evaluate the function. And remember, I could rewrite the function now as this, although I don't know if it's any more beneficial. But you are able to, once you are able to rewrite the function with the factored form in the denominator, you can read off the asymptotes. That's why we did that, right? And so I don't know which one's easier. I think actually the original's easier for determining a y-intercept because we're going to see I'm evaluating the function at 0, so I just get 1 over 0 squared plus 6 times 0 plus 5. So I actually just get 1/5 for the y-intercept. So that's going to be 1/5, positive 1/5 too. It's going to be about in here somewhere, 0.2, right? Okay. So we are now in the point where in order to draw a sketch of this thing, we need to figure out where the graph is in strategic locations. So I know the end behavior typically is like determined by the horizontal asymptote or the oblique asymptote. But in this particular instance, we have a horizontal asymptote. So I know the graph's going to kind of come down here and go towards the horizontal asymptote, right? As I get bigger and bigger values of x. Additionally, I know that I'm not allowed to cross over that blue vertical asymptote. So the only place that this graph can go is up along that vertical asymptote. That's a little too pointy for my liking. I'm just going to try and fix that. It's going to come down here close to the, should be getting closer and closer to that vertical asymptote but not touching, and then curl down at the bottom. That's a bit better. Okay, pretty pointed though, tough to draw that one. And then we just need to figure out where's the graph over here and where's the graph in here. So what I'm going to do is just start checking, where's the graph as x goes towards -1 from the left. So as I start going towards -1 from the left, where is the graph? So I could put in like -2 or -1.5, whatever you want, okay? So I'm going to get, and again, because the graph's kind of sitting, like the horizontal asymptote's at 0, for each of these like points of interest, if you will, I really just care about the magnitude of them. And by that I mean whether or not they're positive or negative. So if I put in, let's say, this means when x is equal to like -1.5 or something close to the asymptote, right? What happens to y? Like, what is the y value when x is -1.5? So I'm just going to check that, right? So f at -1.5 is going to be 1 over -1.5 plus 5 times -1.5 plus 1. Well, I'm going to get 1 over 2, 1's going to be positive here, whatever the number might be, and this other bracket is just going to be negative, which means I'm going to get a negative number when f of x, or when we evaluate the function at -1.5. So that means the thing's going to be down here somewhere. Like at 1.5, the graph's going to be down here, some negative y value, okay? So then I'm going to do the same thing over here because I want to know, like, does the graph go up and up, or does it come up and come back down? I have a feeling it's going to do this for the reason that I don't have any x-intercepts. Why don't I have any x-intercepts? Because I have no variables in the numerator to solve for. Right? So I have a feeling it's going to look like this. I'm just going to give it a quick check using the same method. So what happens as I approach -5 from the right? So that means as I go towards -5, coming from the right, here's the right, as I go towards it, where's the y value go? Do I get a positive y value or do I get a negative y value? Okay, so let's just check that. Okay, so as I approach x, as x goes towards -5 from the right, so I'm going to check something like, let's say, a true statement for something that satisfies this would be like if x is equal to, I don't know, -4.5. So I'm just going to evaluate the function, okay, just like I did the last time. So f at -4.5 is going to equal 1 over -4.5 plus 5 times -4.5 plus 1. Okay, and you're going to see -4.5 plus 5 is going to be a positive number, and negative 4.5 is going to be negative. So again, you're in this situation where I kind of have this 1 over a negative kind of thing happening. So this comes out to be a negative number, some negative number, whatever it might be. Or because it's a sketch, right? It's not really asking me to provide a detailed graph of this thing. It's just a quick sketch, right? And so I know the graph's going to be kind of down here again for some negative y's. It's going to come up here, get close to that horizontal asymptote, and turn around again, okay? And then I've only got one more like area to check. Is like if I check something on the left side, so where's the graph as I go, or I check as x goes to negative 5 from the left now. So something like if x was negative 5.5, that would be a number on the left side of negative 5. And so I'm just going to evaluate the function again. Again, I just carry about the magnitude because my horizontal asymptote's at y equals 0. And so if I evaluate at negative 5.5, I'm going to get 1 over negative 5.5 plus 5 multiplied by negative 5.5 plus 1. Okay, both of those two things, if you look at that, I'm going to get 1 over negative number multiplied by a negative number, okay, which means it's going to be positive, some positive number, okay, which means I'm above the y-axis in the positive area, so somewhere up here, wherever that might be. And then I know it's just going to ride the vertical asymptote, come down, and then take on the end behavior of the horizontal asymptote. Okay, so there's a quick sketch of your graph. That's how I would come up with the sketch. Again, the more points you provide and the detailed y values for specific x values is going to give you a more accurate graph. But that's a pretty good sketch of what this thing's going to look like. And now I can just state the domain and range, right? So the domain is x can be everything. X can be a part of the real numbers such that, okay, x can't equal our two asymptotes, vertical asymptotes, negative 5 and negative 1. Okay, and our range can take on all values of y except 1. And that one unacceptable range value is going to be our horizontal asymptote at y equals 0. Right? So it can be all values of y except y equals 0. Okay? And that's it for these problems. Really, you're just like, they're all kind of the same in the sense that like they have a horizontal asymptote. Some of them have, well, they all have, the quadratics seem to have all two vertical asymptotes in the denominator. So you're going to be in a situation that looks like this for all these problems for the most part. There might be a, you can see here in C and D, you've kind of got a vertical reflection kind of thing happening. So you might end up seeing the graph looking like this kind of thing. But in any event, we'll do those later. Just taking a little, sometimes looking at these questions and kind of asking yourself, like, what do you notice? What do you wonder against each of those four is helpful. And then it enlightens you as to how they might change from question to question.